very much for coming. I have not seen as many people in this office before. I'm normally based out of the London office, incidentally. I've got the London office as well, so I'm normally based out of that office. I think the last time I was in the ThoughtWorks office in Hamburg, it was in the office before this one, and it was literally the size of the conference room over there, so it's probably quite a good job we've just moved. First off, how many people have actually been to GOTO Artists? Has anyone been already? I've got a few hands up. It's fantastic. I've been about 4 times. I can't recommend it highly enough as a speaker or as always an attendee, because it's for me it's pretty much the best conference in the world. I know Martin Fowler always says that if he was not invited to speak so often, then he would actually pay his own money to go. So I mean, it's a really, really good conference. I can really recommend it. And also, to reiterate, I do have a training course running, so if you can fill those 8 spaces, that would be great. So what am I going to talk about? Microservices, adaptive architectures, and organizations. It's an interesting topic. It's something that's sort of come up, I guess, in the last sort of 2 or 3 years. Just as a flavour, we did a survey internally of our projects in Europe, and of I think about 17 or so projects that returned results. Pretty much 2/3 said that they were using some form of microservice style of architecture, which is kind of interesting because I think probably a year ago that would have been hardly any. So that's fine. What is it? Well, that's, I guess, what you're here to find out. I guess initially I'd just like to introduce myself. My name is James Lewis. I'm a principal consultant with ThoughtWorks. I guess I describe myself as a sort of coding architect. That's probably the best description. I spend most of my time on projects, either as a sort of tech lead or as a sort of an architect or writing code as a developer. So at the moment I'm writing C# code. Some of the examples from this talk were from a project about 2 years ago. I was writing Java code back then, so it's Java. So I have to say C# is awesome as a language. I'm really enjoying writing C# code. So in ThoughtWorks, as well as being, as well as my job as a coding architect, I'm also a member of the Technical Advisory Board. That's a group of technologists who get together every 6 months or so. Includes people like Martin Fowler and Neil Ford. And we produce something called the ThoughtWorks Technology Radar, amongst doing other things as well. So if people have come across this before, this is a bit of blatant self-promotion of the staff, but we are in the ThoughtWorks office after all. And the Technology Radar comes out pretty much once every 6 months, and it covers off, I guess, up-and-coming technologies. It's kind of interesting to take a look at if you can download it. That's enough of that. So what's this talk about? As I said, it's about microservices. Well, what are microservices? For me, microservices really cover off 3 things. First thing is that it's about evolutionary architecture, evolutionary approaches to building systems. It's about emergent design and how we can allow our teams to actually, the design of our systems to emerge over a period of time without it being overly prescriptive. And it's also about people and teams. So it's about these sort of 3 things that we've been talking about for quite a long time, and they seem to have sort of come together in the last few years, or couple of years, to sort of form this idea of microservices. It's also about some other things. It's also got some giants, a monolith, the TARDIS, a volcano, some mushrooms, turtles, and a cave in it. So what I'm going to start with is this idea of big systems. Are we building systems that are too big? That's the first question I'd like to pose. And there's some interesting stats from people like Gartner at the moment. This is an example of that. So 90% of the total cost of ownership of a system, of an application, is incurred post-launch. If you spend 1 million building something and getting it into production, you're going to be spending a lot more than that over the lifetime maintaining the big system. There's also, in the United Kingdom, certainly, been a number of very, very high-profile failures of enormous programs of work, big application programs that have failed. In this case, this is NHS, National Health Service in the UK, had to abandon a project after spending 12.7 billion, so I guess that's about 15 billion euros, is it? That's quite a lot of money to spend. And the other thing, and I'm not sure if we've got any CEOs or CXOs in the room, but we have to do this every few years. We have to rewrite these big applications because they become unmaintainable. 3 to 5 years in, you've got this big application, and it's really, really hard to make changes to it at the time. And this is a question I tend to ask, or rather get asked by people when I speak to sort of CXO, chief execs, that kind of stuff, is they're not happy about this. Why do we have to keep spending all this money on these systems, on rebuilding systems? So there's a friend and former colleague, a guy called Simon Stewart. He's now at Google. He's behind WebDriver. I'm not sure if people have come across WebDriver, but he's ex-ThoughtWorks guy. And he has this really lovely idea of storytelling. So he came up with this idea of having a team shaman, which is a lovely kind of thought. Someone who will tell you the story of how things became the way they are. So you sort of start on a new project and you look at this build and it's this tremendously long rake file like this, or AMP file if you're unlucky enough to still be using AMP. And you think, oh my god, this is terrible. This is awful. How could it possibly have been this? How could it possibly get this way? And Simon would gather you around, team shaman, gather you around and say, right, I'm going to tell you the story of the build. I'm going to tell you the story about how the build got to this state. I like this idea of a team shaman. I like the idea of storytelling because they're quite powerful. So I'm going to start off, and there will be a few throughout this, with some scary stories, some sort of nightmares, if you like. But these are all rooted in reality. These are all rooted in the real world. These are developed from work that I've done as a consultant. And actually, some of the people who are in this room from ThoughtWorks, I've worked with on some of these, so you might see some similarities to some reports we've written before. So the first scary story I want to talk about is an airline. It was an airline. It's a UK airline. I'm not going to obviously mention names. It's a UK airline, and they're pretty big. They're doing pretty well. They're rapidly expanding, and they had a system that basically looked like this. You've got some retail site, and you've got some departure control systems, and you've got a big database in the middle of it. Right? That's effectively their system. There's some other stuff, there's billing and stuff. But airlines, when it comes down to it, are pretty straightforward. You've got inventory, which you need to sell, which effectively the seats on your aircraft, and you've got to get people onto those aircraft, airside as they call it. So interestingly, with this airline, we were asked to come in and do a review of their architecture over a period of time. It took about 3 weeks to look at these systems. And what we found, after hearing their stories, is that over time, they had this database, and they had this retail site and this departure control site talking to this database. And as they expanded, as they grew, this database got sort of bigger and bigger. So it started off, relatively small SQL Server database, ended up quite a big SQL Server database, and suddenly, before they knew it, it ended up as an absolutely booming, enormous SQL Server database. That says 48 core, 256 gigabyte of RAM. That's NUMA, so it's not kind of your standard kind of box. It's about $1 million per box. And of course, they've got their architect hats on, so they're not having one of these boxes. They're having at least two in 2 different locations. So that's every time they need to upgrade, they're talking about about $4 million. And that upgrade cycle is about 12 to 18 months. Whoa, that's a lot of money to be spending every 12 to 18 months just on your database. So we got together and we wrote this report for them. And in our report, we wrote lots of kind of, technical, architecturally sound stuff, reasoned arguments relating to systems being tightly coupled to one another, tightly coupled to the database, and golden hammer syndrome, solving every problem with the same solution, just hitting it with a SQL Server hammer, single points of failure, and this led to cost expensive to scale, high operational cost, and high cost of failure, which is great, and the report looks fantastic, right? It's an architecture report. The thing is with architecture reports, they kind of, in the background, or rather in the foreground, have real cost to businesses, right? If you've got these kind of symptoms in your organization, your business is in a pretty shaky position. And to illustrate that, about a year previously when we were there, this happened. It's a volcano. There's a volcano. The volcano went off in Iceland. I'm sure people remember the volcano going off. And there was this tremendous kind of problem with flights and cancellations and this kind of thing. Now, the interesting thing is, if you look at this system, right, what's the first thing people do? This is a question. What's the first thing you would do in the event of you being worried about your flight being delayed or cancelled? You go to the website, right? You check to see whether your flight is delayed or cancelled. And there's lots of people doing this, many more than normal. And of course, it starts to slow down a bit. And what happens when it starts to slow down? Well, you start mashing F5, right? You start doing that. You start F5. They actually DDoSed their own their own site. Right? Now, this would kind of be okay if there was any kind of separation of concerns here at all. But actually, in this case, there wasn't. You've got both of these systems talking to the same database, people mashing F5, and all of a sudden, the database just died, went away, couldn't handle it anymore. And people physically couldn't get on planes. So even the routes that weren't affected by any of this, people couldn't actually get onto the planes because of the coupling between these two systems. They physically couldn't actually check in or actually get, when they got to the gates, get through onto a plane, which is quite scary. I guess for me that's an example of one of these kind of big systems, a big database, everything in the database, golden kind of hammer. The next thing I want to sort of talk about is this idea of Plato's cave, or different types of architecture. So Plato's cave is from one of Plato's dialogues, and in Plato's cave the idea is you've got a person or a row of prisoners actually who are shackled hand and foot, and they're staring at a wall. Behind them is a fire, and people are holding objects up in front of the fire, and they're seeing the shadows on the wall. Now I kind of see, it's all very well me showing architecture diagrams and saying this is how the world is, right? Actually what I'm showing you is the shadows on the wall. I'm not actually showing you the real systems. Real systems actually are obviously much more complex than the diagrams we draw to show people to get money and get sign-off. And this is an example, I guess, of one of these sort of shadows on the wall, one of these kind of one of these platonic forms. This is a system I've worked on. This is really where I first came across and put all these ideas together. It was a system. It was basically like a bank in a box. It's a product. We build effectively a bank, and it has a bunch of different capabilities that enable you to perform different operations that you would in banking. So it has a website, it has some call centers, applications, some analytics, users, transactions, accounts and stuff like that, some rules, rule engines, some reporting, some access and entitlements. The usual stuff you would see in a pretty big complex system. Now, traditionally, what I would have done was do something like this, right? Back then this was Java, so I'm going to download Spring. Spring is going to, with the aid of Maven, download the rest of the internet. And I'm going to put it all into one big application, right? One big application is going to be talking to the database. And I'm going to have all these different, all the different bounded contexts that exist within the system in the same physical deployable application. Generally, that was the traditional way I sort of used to go about building these systems. And it's sort of over a period of time. I guess myself, people like Dan North and a few others, Jimmy Nielsen and so on, we were talking about the idea of bounded contexts and from domain-driven design, and what would happen if you sort of started to tease out bounded contexts that would generally exist within a single application out into separate applications. So rather than have this one big sort of artifact, one big application, for the purposes of the camera, the printer is now going in the corner. Rather than have one big application, what would happen if you started to tease some of these domains, the different bounded contexts, out into separate deployables? Rather like this. And I don't just mean, having several applications talking again to one big database. The scary story I sort of told you is kind of related to that. That's kind of what they did with that. One big database, single point of failure, lots of applications talking to it. Rather than doing that, we actually move the data with the application. So we have bounded contexts that own their own data, separate from one another. And that's the first kind of thing I think about when I think about evolutionary architecture and microservices. It's this idea of having hexagonal business capabilities. So business capabilities in the service-oriented architecture sense, which own their own data. This kind of looks like this. So when I say sort of hexagonal, that's kind of interesting, right? Because hexagonal is kind of related to hexagonal architectures, which have been around for quite a while. It's something called ports and adapters, which I'll cover off in a minute. So in our, I guess, shadow on the wall architecture, what we have is a number of different business capabilities, which we separated out into completely separate applications, each owning their own data, and each, as we'll see later, eventually consistent between one another. And in the case of a single business capability, this is another example, we had a capability that was decomposed into yet more applications within the business capability. And I think when we talk about microservices, this is generally the sort of thing we're thinking of, is having many small applications doing the job that would previously have been done by one big application. So in our case, we had an event queue, we had backed by an event store, we had some queue processes which were implementing the kind of competing consumer pattern, polling that event queue, and we had a user service which was the source of truth for data for users in our system. And this was a single business capability, but within it, it had 3 independent applications. I actually had 2 databases, one of which was MySQL, one of which was Mongo. So choosing different technologies as well. Well, that's all very well, but if you've got these different capabilities talking one to another, and the applications within these capabilities talking one to another, you kind of need some way to allow them to do that in a fairly consistent manner. And the next point is this idea of these capabilities share a uniform interface. In our case, it was the uniform interface of HTTP, but the current project I'm on is actually not using HTTP, we're actually using messaging, and you can do the same thing with messaging infrastructure as you can do with this. So, for our sort of hexagonal, for our hexagon or business capability, we ended up with this idea of ports and adapters on the kind of vertexes, on the edges of these hexagons. So port and adapter pattern basically says we'll have a kind of standard way of adapting input and output to an application. So in our case, what were we going to call that? Well, what were we going to use? Is we had this business capability. And by the way, I should point out that these circles here, this is official Arcanate open group from the people who brought you MoDAF and TOGAF. This is proper architecture now. This is real stuff. Yeah. What were we going to use? Well, there's a few options, right? In this case, there's a few options. I'm going to tell you another story. And this is a real sort of capability map of a client. It's pretty cool. Although the colours, this is known as the rainbow diagram, for obvious reasons. The colours represent different types of data, so by domain. So say green is user data, right? So we've got user data pretty much spread all over the place. All of these things are talking via direct database access, database to database. In some cases, via something brilliantly called the middleware database. We actually don't have middleware, we have a middleware database, which is fantastic. Yeah, and as we can see, there's stuff spread around all over the place. And this is a classic example of something called the Stovepipe enterprise. The Stovepipe architectures have been known about for decades now. This is 99, the quote, systems procured and developed to solve a specific problem characterized by limited focus and functionality and containing data that cannot be easily shared. And that's kind of one option for us, And actually, most organizations have a lot of this going on. There's lots of ETL, there's lots of direct database to database. That's pretty common. And this, in general, is only kind of a small part of what a large organization's system estate usually looks like. It's kind of more, I guess, like that, right? It's lots and lots and lots and tens and tens and tens of systems all talking to one another by the database. So, again, when we put a report together, as we are wont to do, we talked about the idea of logic being scattered, about data being scattered, and then it becomes very difficult to predict the effect of change, which system is the source of truth for any data, where do you go? Where do you go to change? Where do you go to get the idea of a user from? You have to go to 20 different places. I was actually at an organisation where they had a system that looked at, well, kind of architecture that looked a bit like this, and they had this kind of mishmash of databases, and they'd run 12 projects over the previous 2 years to try and integrate, to try and sort of separate off from these databases and integrate with them. And every single project had failed. They'd spent millions upon millions of euros trying to address this, and just actually couldn't come to the point where it was almost physically impossible for them to do anything about it. So, I'm hoping we're agreed in the room that this is maybe not the best approach to take towards systems integration. There is another, or there are several other approaches, messaging and so forth, but when 2 years ago we were looking at this product, this bank in a box, we decided to look at the uniform interface provided by HTTP, basically. And this is a brilliant talk online. I don't know if you've seen this. A guy called Leonard Richardson. This was 2008 at QCon. It's 2013, so it's 5 years ago. And we still haven't even, I guess, taken a lot of this stuff on board, which is quite scary. This is, yeah, as I say, QCon 5 years ago. He talks about a really, really interesting idea, really interesting concept. He talks about his maturity heuristic. And his maturity heuristic is about how we integrate between systems and the different maturity levels of integration between systems using HTTP. So the first level, which is level 0, is this swamp. He calls it the swamp of POCs, so it's plain old XML. Level 1 up is you introduce the idea of resources into your integration scenarios. The next level up is you introduce HTTP verbs, so you don't tunnel commands via URLs, for example. You actually use the correct verbs from HTTP. And finally, you have the crowning glory of REST, which involves using hypermedia controls. And the great thing about hypermedia controls is that they allow you to decouple, to a certain extent, client and server interactions. I have to put this in because it's my favourite slide ever. Behold, the twin fists of hypermedia as the engine of application state. Yeah, so based on looking at RESTful patterns, based on some work that some colleagues, Jim Webber and Ian Robinson, have been doing, we decided to go and look at using a RESTful style to integrate these business capabilities, and also integrate the smaller applications within those business capabilities. So what did that look like? Well, very simply, these resources ended up offering up representations in some cases HTML, some cases XML, and some cases JSON, which included things like hypermedia controls, so you were able to manage state changes within the applications using those hypermedia controls. So as an example, we have, I think this is a page for a user, for creating a user. We have a form in here which actually has default values which you can fill out automatically using a client, HTTP client of some sort, and submit. It also has things like other controls that link off to indexes, user indexes. So, what we ended up with in our platonic world, in our kind of platonic boxes and arrows world, what we ended up with is a capability that looked like this. Again, but with the interfaces to the outside world effectively being HTTP with well-known content types. In our case, we were using Atom and JSON. I guess probably OData is more fashionable at the moment. But simply, we had some. We were exposing some resources. In this case, a user request and a list of user requests and a specific user request in a standard content type. So the next thing about microservices, and this is what people kind of tend to focus on, is small with a single responsibility. So single responsibility principle all the way down. You're probably familiar with Terry Pratchett. He talks about its turtles all the way down until you hit the elephants. I don't think there are any elephants in this case, unless you get right down to the bottom and you hit the go to the bottom. But single responsibility principle as applied all the way up and all the way down. So what does that mean? Well, we've got our capability, which has an application within it. Actually, it's probably a bit more complex. The one we were talking about had 3 different applications and 2 different databases. And each of these has a single responsibility. Each of these has the responsibility of achieving a particular goal and has the business rules within it to achieve that goal. So we had, as I said, we had an event queue, we had a user service, and we had an event processor. Each of those things had single responsibilities. And when you dive sort of into, I guess, one of these applications, generally they're composed of objects in an object, in an OO language. And then when you dive down into the objects, basically you hit my conjecture, which is that these things should be no bigger than your head. Now this is actually, Dan North is teaching this on a course, which is bizarre. But this comes from a project I was on where we made the observation that if a class gets bigger than my head when I put it up against the TV screen, then it's too big. At that point, it's going to have probably more than one responsibility. But that's okay, because actually there's not much in my head, so it's fine. It's kind of an empty head. It's quite big, but it's quite empty. So, single responsibility principle all the way down. When you get to the bottom, this is where we normally talk about single responsibility principle with respect to object-oriented programming, with respect to objects. But actually, you can apply this as you chunk up different levels of abstraction within your systems. So when you chunk up to the level of an application, the application should have a single responsibility, should do a single thing. When you chunk up again to the level of a business capability or service, business service, it should have a single responsibility, it should do one thing. And similarly, when you chunk up to the level of systems, they should also have a single responsibility and do one thing. So as we chunk up these levels of abstraction, each of these domains, effectively we're chunking up through different domains. We're chunking up from the domain of objects into the domain of applications, into the domain of capabilities, into the domain of systems. Each of those domains should be small enough to fit in my head. I should be able to understand them. And what did that mean in our kind of Plato's cave world? In our case, it meant about 100 or so, maybe about 500, certainly less than generally 1,000 lines for each of these little applications. They were tiny, really, really small, doing one thing only. So at this point, quite a lot of people sort of start to say, well, what about reuse, right? What about reusing domain code and things across these different applications? So I've got a word about reuse, and that word is don't reuse domain code at all. Well, not domain code, yeah. Of course, I'm not saying don't reuse any code, and an excellent example of reuse is the sort of, and it's becoming very popular, is the external or sometimes internal open source model that a lot of organizations are adopting. So an example of that would be Netflix. At Netflix, this is an example from Netflix, I think it's from their open source website. Obviously it's Netflix, so they have each of these as a film, but actually in the back, behind this, if you hover over it, each of these is a small utility they've created to help their developers solve common problems. It tends to be infrastructure code though. It's all infrastructure code. It's a Cassandra library to help you talk to Cassandra. It's something to allow auto-scaling to be more effective on AWS. It's infrastructure code. Don't reuse and don't share domain code. So the next point I'd like to bring up is this idea of standard application protocol. So what we're talking about at the top level of HTTP with Leonard Richardson is, I guess, HTTP as a protocol. When we talk about application protocols, I mean something slightly different. I'm not sure if this joke translates at all into German, but Noam Chomsky, it does, excellent. Noam Chomsky is obviously a very interesting philosopher. He uses the phrase, time flies like an arrow, fruit flies like a banana, to describe the difficulty that computers have in understanding language and processing language. I mean, those two sentences are actually identical, but the meaning is very different in English, even though the structure is actually identical. It's hard to program machines to actually understand the nuances involved in processing natural language. So what does that mean when you're trying to build and connect lots of these small applications? Well, it means you're in a bit of a pickle, frankly, unless you do something like choose a standard protocol. So this is because, this is what I'm talking about, is the idea of something called the semantic gap. The semantic gap, I'm going to read it, characterizes the difference between two descriptions of an object by different linguistic representations. That sounds kind of trivial. Effectively what it means is, if you've got one interface that's exposing a link or control with a reference register to create a user, and another one, create, how do you program a client to know which of these hypermedia controls they should be using? So we standardized on an application protocol. In fact, and as I say, because Jim Weber and Ian Robinson, to a large part, worked with us for a long time, they wrote this fantastic book, Rest in Practice. I don't know if people have come across this. We standardized on RFC 5023, which obviously everyone can immediately identify as. No, I'll give you a hint. It's basically Atom Pub. So this is more usually seen when you're trying to when you're reading blogs or in your feed reader or so on. But you can do really interesting things with Atom and Atom Pub or OData in I guess as the hipsters would use now. Atom and Atom Pub, it standardizes the sorts of things you can do between these systems, the sort of operations you can perform effectively. So it describes the idea of workspaces, which are composed of lists of collections with some metadata. These are composed of these collections individually. Those collections are then composed of entries, and the entries are composed of content. Now, I'm going to go out on a limb here and say this is basically SOAP. Remember WSDL? WSDL, this is effectively SOAP, kind of, in the sense that what you get with this standard protocol is an envelope and a set of operations that everyone can understand. It's obviously not what happened with WSDL. With WSDL, you can put anything you kind of like in there. But it did have the idea of an envelope with common metadata and then a payload underneath it. What Atom Pub does is give you, on top of that, on top of the envelope and the payload, a set of standard operations. Which means when you've got systems of systems talking to one another, you have a set of standard operations that you can program clients against. And that's a really useful thing to be able to do. So in our world of hexagons again, this might look like post on one side, post to a user's collection, and post to a user's collection on the other edge. And in this case, this is an example of the post. We're posting an Atom entry in order to create a user. But that's a standard. That's something that the standard, the RFC, gives you. And all of your applications are able to use that standard and understand how to go about adding, deleting, editing particular bits of information within your domain. I'm going to reiterate, I'm not saying everyone should use Atom Pub all the time, because I think that would be crazy. You should pick the right solution, obviously, for your particular set of circumstances. So if it's messaging, it's going to be a different solution. And it might be an internal application protocol that you develop. But it's very useful to have this idea of a common application protocol that each system can use to talk to one another. So back to our capability. In this case, we had a user request collection, and we had entries underneath the user requests, which you basically you post Atom entries into the collection, and that would represent the creation operation for a user. So the next thing, I think is really important point, is this idea of architectural degrees of freedom within your system. The idea that we should be able to flex in multiple different ways, as much as possible, the systems that we build around different axes. So back to my scary stories, you'll be pleased to know. So in this case, it was a client. This is about 3 years ago now, and they had a fairly standard big database, big application sitting on top of it. The interesting thing with this client is they had multiple different products, different product lines. It was insurance effectively, the different product lines within this application. So they had sort of home insurance, they had car insurance, they had credit card insurance, lots of different products within this one single application. And that was fine. That was fine. But they had some interesting constraints, specifically around things like scaling for performance. The home insurance part of this application had a reasonable number of users. The money kind of part of it didn't have that many at all. But actually car insurance, as everyone knows, is a massive volume trade, right? This is where people make money. They make money by volume. They had loads and loads of users. And the scary thing with this, if you've got this one big application, is that you can't take advantage of the fact that you could put these onto different size machines. So effectively, you're bounded by the biggest application that you have. And there was another problem that they had, and this was a real business problem because it meant they couldn't actually change anything. So they had this one big application, and one of the products, or several of the products, all of them had different change cycles. So the motor insurance site, say, was quite stable, whereas the home insurance was being actively developed. Now the problem comes when you've got these two things, these cycles linked together. And people have come across value stream maps, very popular in the kind of lean world. And this is kind of a real value stream map of this organization, which is how long it took to actually get stuff done for a particular one of these products. So in the value stream map, the top lines are the value-adding activities, basically. So it might be 3 days worth of development, 1.5 days of testing, and then half a day of performance testing, say. But on the bottom, you've got the amount of time they had to wait for other activities to go on. So effectively, if you add up all of that, a single change was ended up taking a massive amount of time. They wanted to change an image for one particular product, and they had to wait on the release cycle of a completely different product. And this was having a massive impact actually on the ability to get stuff done, both in the teams, and was really limiting the ability of the business to get change out the door and make effectively more money, which pays our wages, which is awesome, which sucks. So if you've got this world of sort of micro applications, microservices, different business capabilities, how does that impact this kind of these degrees of freedom? Do you have more degrees of freedom? Well, I think you do have more degrees of freedom when you break things out into smaller chunks, when you separate different parts of your domain, different bounded contexts out into separate applications. You can, as an example, deploy the capabilities on different boxes, right? You can deploy more than one of them on a box. You can deploy 2 or different ones on the same box. You've got more options, you've got more flexibility, you're able to better fit your deployment options with your performance and with your change cycles and so on. I did sort of have a title, Adaptive Architectures and Organizations, but I think that's a really important point. Part of this is the idea of where teams fit in and where things like technology choice fit in this world. Now, probably doesn't surprise you, I work for ThoughtWorks, and at ThoughtWorks, we're kind of a big believer in using the right tool for the job, not being limited by using a single tool all the time. And what these sorts of architectures give you, again, is more degrees of freedom when you come to choose different tooling, different implementation. So, as an example, the client I'm on at the moment, the project we're working on, we've got a number of these different business capabilities split out. We've got, it's generally a .NET shop, so we've got two of them are implemented in C#, and then we've got a Node service. Well, it's a capability that's doing our real-time monitoring. So it's an event-based system, so we've got lots of really cool real-time kind of eventing going on, and we're able to monitor that, and we're using Node and a few tools on top of Node to do that. But it's great because we can actually choose the right tool within the bounds of that capability. You can give your teams the option, the ability to choose the right tool within each of these bounded contexts. Similarly, we're actually using different databases. So the reporting database is SQL Server. I think we've got, there's another SQL Server database. We're actually using Mongo for our production environment, for our kind of event stores and this kind of stuff. We're able to choose different tools depending on the right characteristics of the tool to the problem we're trying to solve, rather than it being one big thing that we have to use one thing to implement. I saw someone with a Node t-shirt on. That probably makes you happy. Okay. And finally, well, not finally, penultimately, I'm going to talk about design for replaceability. And I think this is a really powerful idea as well, because if you've got these business capabilities which are protected by the kind of hexagonal boundaries of the ports and I've forgotten the word now, the hexagonal business capabilities. If they're protected by a kind of standard interface that they're talking to the outside world you can actually, within those, you can actually replace parts of them, and they're isolated from other parts of your system. So as an example, we actually started off, this is the current system, we started off with SQL servers and a Mongo database, and we decided that actually we'd probably like to use Neo to do some big data-y analytics stuff. And that's fine. We could actually implement that using ports and adapters and actually get rid of the other one. Now, these applications are small. You know, the actual cost of replacing these things of 1,000 lines of code is not that great. The cost of replacing 200,000 lines of code when you've got a really big application, that's significant. The cost of finding a seam to be able to hive off a part of that application, the cost of that is significant. But this gives you a different options, different degrees of freedom when it comes to replacing parts of your application, designing for replaceability. I actually think that should be, it's on the Software Engineering Institute's non-functional requirements list, as a new sort of non-functional requirement, along with maintainability, performance, these things. So finally, I'm going to talk about product teams and product lines. And this is something that's sort of emerged very much from the kind of lean software engineering kind of movement. It fits very well with continuous delivery and the continuous delivery techniques that a lot of people are implementing now. But it also fits very well with this. Why do I say that? So this is a sort of standard enterprise, right? You've got your project management office, you've got your operations group, you've probably got some developers in a silo, you've got some testers, there's lots of handing of requirements between the two. The project management office kind of wanders around, bossing everyone about. Apologies to the program managers in the room. And then on the other side of this dotted line, you have, quotes, the business. And Dan North and Martin Fowler did a talk, I think it was called The Yawning Crevasse of Doom. It's not so much a divide, it's this enormous gap generally between IT departments and the businesses that they partner with. If you think about the idea of product lines and product teams, and this is the idea of effectively bringing cross-functional teams together, organized around specific products. And in our world, in this world, you've got these business capabilities which can implement specific products. Then you kind of start to look a bit more like this. You can have individual teams formed around these individual products. And this is kind of nice, because this is something that has sort of been bubbling around, I think, in the industry for a while, the idea of Conway's law. When I say a while, Melvin Conway wrote this in 1968. So organizations which design systems are constrained to produce designs which are copies of the communication structures of those organizations. Dan North says, if you ask 7 people to write a compiler, you'll get a 7-pass compiler. Basically, it's the reason you get database teams, service teams, or middleware teams, and web teams. Right? It's the reason you get websites talking to services, talking to a database, if you structure your organization in that particular way. Right? Well, I think there's an opportunity to actually use this idea of your systems mirroring your team structure to actually reinforce some of the architectural kind of goodness that we kind of think about, right? So we can actually model our teams around these capabilities, which are modeled around product lines, and reinforce the distinctions between these different systems. So in this world, back to this set of capabilities, what that ended up looking like was a number of teams. And these are story points on the red cards and team sizes. But each of these teams was distinct and was delivering 1 or 2 capabilities. So, at the start I said I wanted to talk about evolutionary architecture and emergent design and microservices. So really what I've talked about, I'm sure people in the room are aware, is standing on the shoulders of giants. A lot of this stuff is not new necessarily. In fact, most of it isn't new. Domain-driven design, bounded contexts, using REST to do systems integration, right? Using things like Conway's law, using principles from Lean to structure teams around products, designing your systems such that you have different architectural degrees of freedom. These things aren't new, right? In fact, there's books written about them, and there have been for decades. So we've got Release It, awesome, domain-driven design, just Humble's defies continuous delivery, REST in practice. Well, what really, I think, this idea of microservices does is brings a lot of this stuff together in one place. It says, maybe we have the opportunity to do all of this all the time. And it reminds me quite a lot of Unix. I mean, that's my background. I'm a Unix dude. I haven't got my sandals, and I've shaved part of my beard off, but I can't get rid of all of it, you know. That would be betrayal. But it kind of reminds me of Unix in a lot of ways. And this is a quote from the Lion's commentary on Unix 2nd edition. This is a commentary on when Unix was first, effectively the OS was first written, when the original metaphors came about. And this is about when they had the idea of pipes and filters in Unix. And it says, the next morning we had this orgy of one-liners. Everyone had a one-liner. Look at this, look at that. Everyone started putting forth the Unix philosophy. Write programs that do one thing and do it well. It sounds like the single responsibility principle to me, right? Write programs to work together. Write programs that handle text streams, because that is a universal interface. The ideas I'm talking about go back decades and decades. We seem to somehow have managed to get ourselves into a situation as an industry where we just build these massive, massive monoliths and don't necessarily think about all the stuff we've learned over a long period of time. And incidentally, if we replace, I guess, pipes with HTTP as an exercise for the watcher, that kind of works out. So really I'm talking about, as I said, consistent and reinforcing practices. These hexagonal business capabilities that are composed of these kind of microservices, micro-applications, and these you can basically rewrite rather than maintain. And they form this idea of a distributed bounded context, the hexagon, this business capability. And then you can deploy them as you like, but generally using things like containers, OS operating system services and interesting stuff like that. And use a standard application protocol and transfer protocols between them. And also standard message semantics. And finally, the cool thing with this, and the thing that probably makes this relevant, more relevant now than it's ever been, is the prevalence of infrastructure as a service providers. So this would have been really hard to do without things like Chef, Puppet, AWS, Roku, whatever you're going to look at. Layering the functionality, layering the power you get from all of those automation tools on top of these ideas, it gives you really, really interesting options for the future. So again, architecture is all about trade-offs, right? Maintainability. This is the degrees of freedom. Maintainability in time to market, throughput and cost, say, portability versus deployability, and replaceability versus cost of adding new features. But basically, evolutionary architecture and version design are approaches using these sort of techniques that maximize the options you have, maximize the degrees of freedom that you have within systems. I have no idea what time I've gone through, but thanks.